Imagine a time before time existed, a moment so primordial that even the concept of time had not yet been born. A time before light illuminated the vast expanse of nothingness, a void so complete it defies comprehension. This was the state of the universe before the Big Bang, a point of infinite density and unimaginable heat, where all the matter and energy of the cosmos were compressed into a single tiny point. Then, in a fraction of a second, everything changed. A cataclysmic event that would set the stage for everything that followed. The universe exploded outwards, expanding rapidly in all directions, creating space and time as it went. It was the birth of everything we know and love, from the smallest particles to the largest galaxies. The Big Bang was not just an explosion of matter, but a release of energy on a colossal scale, a burst of creation that would shape the universe. As the universe expanded and cooled, this energy began to condense into matter, forming the basic building blocks of everything. Tiny particles, the building blocks of everything we see around us, began to form. These particles were the seeds of future stars, planets, and galaxies. These particles, protons, neutrons, and electrons, interacted with each other, forming the first atoms, the simplest elements like hydrogen and helium. This early universe was a chaotic place, filled with a hot, dense soup of particles, a cosmic broth from which everything would emerge. But over millions of years, gravity started to exert its influence, pulling particles together. Regions of slightly higher density began to pull in more and more matter, growing ever larger and denser. This process, the clumping together of matter under gravity, is what eventually led to the formation of the first stars and galaxies, the building blocks of the universe as we know it. Within these dense clouds of hydrogen and helium, the first stars ignited, marking the beginning of a new era in the universe. Nuclear fusion, the process that powers the sun, began to occur within their cores, releasing unimaginable amounts of energy and light. These early stars were colossal, much larger than any we see today, shining brightly across the cosmos. They lived short, brilliant lives, eventually exploding as supernovae, which were spectacular cosmic events. These supernovae, while marking the end of a star's life, were crucial for the evolution of the universe, spreading essential elements. The intense heat and pressure within these explosions created heavier elements, such as carbon, oxygen, and iron, which are vital for life. These elements, scattered across the cosmos, became the building blocks for future generations of stars and planets, seeding new solar systems. Over billions of years, this cycle of star birth and death continued, driving the dynamic evolution of the universe. Galaxies, vast collections of stars, gas, and dust, formed and evolved, creating the large-scale structure of the universe. Our own Milky Way galaxy, a swirling disk containing hundreds of billions of stars, is just one of trillions of galaxies in the observable universe, each with its own unique story. Around a relatively young star, our Sun, a disk of gas and dust began to coalesce. This protoplanetary disk, swirling and colliding under the influence of gravity, slowly gave birth to the planets of our solar system. Among them was Earth, a rocky planet orbiting at just the right distance from the Sun. The early Earth was a hostile place, bombarded by asteroids and racked by volcanic eruptions. The atmosphere was a toxic mix of gases, devoid of the oxygen we need to breathe. Yet, beneath this seemingly inhospitable surface, the conditions for life were slowly emerging. Volcanoes released water vapor and other gases from the Earth's interior, forming the first oceans. The cooling planet and the presence of liquid water created an environment where complex chemistry could occur. This was the primordial soup, a rich broth of organic molecules, the precursors to life. Within this ancient ocean, a remarkable event occurred, the emergence of life. It was a time when the Earth was still young, its surface a tumultuous landscape of volcanic activity and meteor impacts. The exact details of how life arose from non-living matter remain a mystery, but we know it involved the self-replication of complex molecules. These molecules interacted in a primordial soup, driven by the energy from the sun and the Earth's own geothermal heat. These molecules enclosed within membranes form the first cells, the fundamental units of life. These protocells were the precursors to all living organisms, setting the stage for the incredible diversity of life that would follow. These early life forms were simple, single-celled organisms, but they possessed the incredible ability to reproduce and evolve. Through countless generations, they adapted to their environment, gradually becoming more complex. Over billions of years, life diversified and complexified. From simple beginnings, life branched out into an astonishing array of forms, each uniquely adapted to its niche. From these humble beginnings arose all the plants and animals we see today, including us, humans, capable of contemplating our own origins in the vast universe. Our journey from single-celled organisms to thinking beings is a testament to the power of evolution. The story of the universe, from the Big Bang to the emergence of life on Earth, is a testament to the awe-inspiring power of nature. It shows how the cosmos has evolved from a chaotic explosion to a structured and life-supporting environment. It is a story of cosmic evolution, of matter transforming and organizing itself into ever more complex structures. Galaxies, stars, and planets formed, creating the conditions necessary for life to emerge. And it is a story that continues to unfold, with each new discovery revealing more about the wonders of our universe. As we explore the cosmos, we gain a deeper understanding of our place in this vast, ever-changing tapestry.